Hi, this is Smita. Welcome to my channel Physics Pathfinder. Today, we are going to explore another topic of Einstein, which is the photoelectric effect. In 1921, Einstein received Nobel Prize for his work in the law of photoelectric effect. Einstein's contribution to the quantum mechanical theory, especially the photoelectric effect, and the light as a quanta paved a new way for a branch of physics called as quantum mechanics. In today's session, we are going to study about the particle nature of light, the concept of threshold frequency, work function, and the concept of maximum kinetic energy. Before that, let me request you to like and subscribe my channel and press the bell icon to get the regular updates. The concept of quantum mechanics started with a problem or a puzzle called as ultraviolet catastrophe. This is basically a quantum mechanical problem. What we knew before was the black body curve. What is a black body curve? A black body curve is a graph of intensity versus wavelength plotted for different bodies, different black bodies, particularly the stars, at different temperatures. And we had seen from the Wien's displacement law that the maximum wavelength for a hotter body is lesser. That is, as the temperature increases, the maximum wavelength reduces. This was the black body curve, which was given by the Wien's displacement law. But what was the ultraviolet catastrophe? Ultraviolet catastrophe is the discrepancy in the reality and the classical physics theory. Reality showed, or the black body curve showed, that at a higher frequency or extremely low wavelength, the energy is very less. But classical theory proved that at extremely high wavelength, extremely high frequency, or extremely low wavelength, energy is infinite. So this was a problem according to classical physics, which was not classical physics was not able to solve this problem. Planck's theory. According to Max Planck, any atom which is oscillating because of its high temperature is allowed to emit energy of a particular value, not a continuous value. Any packet of energy, any energy that is emitted by a hot body is of a particular fixed value, and that is given by the equation E is proportional to n times the frequency. So we can see the equation that E is equal to n into h, which is Planck's constant, times the frequency. Planck's constant is given by 6.63 times 10 to the power minus 34. And this is called as the Planck's law or the Planck's hypothesis. Other way to write the energy equation instead of frequency is in terms of wave speed and wavelength, which is hc over lambda. So the incoming radiation is given by hf or hc over lambda. Here came the concept of quanta. Max Planck introduced the concept of quanta of energy or fixed amount of energy, for which he received a Nobel Prize in 1918. So let's see what is quanta of energy, or basically what is a quanta. Quanta is anything which is extremely small. So quantum physics is a branch of physics which studies about extremely small things. Quanta of cash, quantum of human population, quantum of charge, and so on. Now, there were two natures of light, wave nature and particle nature. Thomas Young, through his experiment of interference, that is the Young's double slit and single slit experiment, studied the wave nature of light. On the other hand, Einstein studied the particle nature of light through the concept of photoelectric effect. And in our today's session, we are going to explore this particle nature of light and study the entire setup of photoelectric effect. So let's move forward. So let's see what is photoelectric effect. Photoelectric effect or photoelectric emission is when any electromagnetic radiation, when falls on a photosensitive material, it carries energy. When this energy is given to the electron that is on the surface of the metal, when the energy is sufficient to pull out the electron from the metal surface, the electron emission starts. And this process of electron emission, after it has absorbed the energy from the incoming radiation, is called as the photoelectric effect. You can see here. Let's see the setup now. Photoelectric effect consists of a CRT tube. A CRT tube had three parts: the collector plate, the emitter plate, the quartz window, the variable power supply, the ammeter which measures the photocurrent, and the voltmeter which helps you to change the voltage. Now, what is a quartz window? A quartz window is basically a specialized window which allows you to take in only the UV radiations. So it allows the light of only one frequency, and that too only ultraviolet radiations. So if you can see the setup, initially the emitter plate was positively charged and the collector plate was negatively charged. Let's see the further part of the experiment. Initially, the emitter plate was negatively charged and the collector plate was positively charged. There was a quartz window which let in radiations of a particular frequency and a particular intensity of light. So as the intensity of light increased, what happened was this negatively charged emitter plate repelled the electrons, because of which the electrons started moving or migrating towards the positive end of the collector plate. Now, as the intensity of radiation increased, we could see there were more number of electrons emitted. So can any light radiation of any intensity give out electrons? No, that is not the truth. There is a minimum required frequency called as the threshold frequency. If the incoming energy of light is lesser than the threshold frequency, irrespective of the intensity of light, there would be no photoemissions. So the first basic necessity is the incoming energy of light should be greater than the threshold frequency. If that is sufficed, then increasing the intensity of light will increase the number of electrons. The next setup was reversing the polarity. During the reversal of polarity, the emitter plate was now positive and the collector plate was negative. So now you can see it's a negative effect. The electrons are attracted to the emitter plate and are repelled from the collector plate. So more and more negative you make this voltage, it would be more difficult for the electrons to move to the other end. Hence, there is no flow of electrons, and hence it should record a zero current. And that voltage for which the current is zero is shown in this graph as the stopping voltage. So stopping voltage is that negative voltage for which photocurrent is zero. What you see is the saturation current for various intensities of light. At lower intensity, the current is lesser. As you increase the intensity of light, the saturation constant current increases to a particular value, provided the frequency is greater than the threshold frequency. Now we can see the effect of frequency on the negative voltage called as the cutoff voltage. We can see that higher the frequency of the incoming light, more is the stopping potential. We can see what we have done till now, a summary of what we have done till now. We can see here, intensity affects the number of photoelectrons ejected, while frequency, provided if it's greater than the threshold frequency, affects the energy of the electrons. So one part of the energy goes in pulling the electrons. The remaining energy comes as the kinetic energy of the photoelectrons. Now let's go to the law of photoelectric effect. The first law of photoelectric effects tells you that if the light has a frequency greater than the threshold frequency, then the photocurrent is directly proportional to the intensity of light, which we have just completed. For any material, if the frequency is greater than the threshold frequency, only then photoemissions will take place. Intensity of light otherwise has no effect on the photoemissions. And lastly, maximum the kinetic energy of the photoelectrons increases. That is, the maximum kinetic energy of photoelectrons increases only when the incoming energy is higher. That is, more the incoming frequency, some part of that energy is used as work done to pull out the electrons. Remaining energy goes as the maximum kinetic energy of the photoelectrons. And photoemission is an instantaneous or a spontaneous process. Let's now study the photoelectric equation in detail. So you can see here, photoelectric equation has three parts. The first part is the incoming energy, which is HF. The second part is the work done to pull out the electrons from the metal surface, called as the work function. Work function depends upon the threshold frequency. And the remaining energy goes as the kinetic energy of the photoelectrons, which also is given as EV0, which is called as the electrical potential energy also. So this can either be half mv square or EV0. Now let's see how can we use the equation for doing sums. For doing sums, you are either given the incoming frequency or wavelength. If frequency is given, you use HF. If wavelength is given, you calculate using hc over lambda. All of these are the units in joules because it's energy, so it is measured in joules. The next part of the theory includes the concept of work function. Work function is again given as h times the threshold frequency. Work function can either be in joules or in electron volts. So please understand, if the incoming energy is in joules, work function is in electron volts. Kinetic energy is also in electron volts. Can you add them? We cannot. We cannot add apples and oranges and tell apple oranges together, right? So it's important to convert all the energies in the same units. So for that, we have the conversion. If the work function is in electron volts, convert 1 electron volt as 1.6 times 10 to the power minus 19 joules. Make all the parts of the equation in the same units. And only then you go for the further answering. That is the common mistake seen. And if anything is in joules, then divide your answer by 1.6 into 10 to the power minus 19 to convert your final answer to electron volts. Let's see graphically. Graphically, if I rearrange the photoelectric equation where kinetic energy is the subject, then comparing it to an equation of a straight line, we can see the y-axis is kinetic energy, the x-axis is frequency, slope or the gradient is the Planck's constant, and the work function is a negative y-intercept. So when you solve graphically, the y-intercept or work function gives a negative value. That's why when you put negative value of work function in this equation, the answer becomes positive. And slope, please understand, should always be the same. Work function is same for a given metal surface, but the gradient or the Planck's constant should also be the same. And the x-intercept is the threshold frequency. You can see here. So let's sum up the observations that we have seen till now. For a given metal, that is a photosensitive material, photocurrent is directly dependent on the intensity of the light, provided that intensity is greater than the threshold frequency. The saturation current also depends on the intensity of the light of a particular frequency. At the same time, the frequency is also affecting the stopping voltage or the retarding potential. The photoelectric effect does not occur below a certain frequency, which is called as the threshold frequency. The stopping potential is directly proportional to the frequency of the incoming light. So the fraction of energy transferred to the electron, one fraction goes in pulling off the electron from the metal surface, and the other part goes in giving maximum kinetic energy to the photoelectrons. Let's now solve few exam style questions. Pause the video, try to solve and come back for the answer. So if you have seen here, the monochromatic electromagnetic radiation ejects photoelectrons from a metal surface. The minimum frequency, that is the threshold frequency given is HF. So this is the minimum energy, that is HF. So if you can see here, this is the threshold frequency. The incoming energy is 2HF. If the incoming energy is 2HF, kinetic energy is K. What will be the kinetic energy if the incoming energy is 4HF? So if you can see here in the photoelectric equation, 2HF, if it was the incoming energy, is equal to the threshold energy, which is HF plus the kinetic energy K. So we can very clearly see that K is just HF. Let's apply it to the new situation. The new situation tells you now the incoming frequency is 4. So the incoming energy is 4HF. The threshold frequency is HF. So you can subtract HF from here. What is left is 3HF, which is 3K. So your answer should be C. Let's see the next one. Pause the video, try to solve, come back for the answer. If you can see here, light of frequency, particular energy is given to you. So this is the incoming light, which is HF. Work function is given to you, which is based on the threshold frequency. When you subtract the two, you get the maximum kinetic energy, or EV. When you subtract the 2, you also get EV0. So if you subtract the 2, the answer is 3.2 into 10 to the power minus 20. If you divide that answer by E, you get the V part, which is the answer. So the answer should be 3.2 into 10 to the power minus 20 over 1.6 into 10 to the power minus 19. You're supposed to do it without calculator as it is paper 1. Your answer should be A. Let's go into theory question. Theory question clearly tells you they are giving you a stopping voltage in this question. The first is a theoretical question to define or describe what is photoelectric effect. So basically they are expecting 2 points, which should be that photoelectric effect is nothing but the emission of electrons when you give a certain amount of energy which is greater than the threshold frequency. Next part is calculating the velocity of photoelectron and prove that it is 700 kilometers per second. So here you're only given the stopping voltage and you're asked to prove kinetic energy. So here I feel we can use the equation EV0 is equal to half mv square, where m can be the mass of the electrons, which is already in the data booklet, which is 9.1 into 10 to the power minus 31. So if you rearrange the term and get the answer for V, which is the velocity of the electron, you should get this answer, which is approximately equal to 700. Last part, you can see work function is given to you. Calculate the wavelength of radiation of the incident radiation, that is lambda. So you have to calculate the incoming wavelength of frequency of the light, where you already have the stopping potential. So you can see here work function is given to you. So you can use the equation work function plus the stopping potential gives you the total incoming energy. When you get the total incoming energy, substitute as hc over lambda, make lambda as the subject, which is hc over E, gives you the answer of wavelength. So that's all for today. Kindly like and subscribe my channel and press the bell icon to get the regular updates.